Using the most advanced Earth-observing laser instrument NASA has ever flown in space, scientists have made precise, detailed measurements of how the elevation of ice sheets in Greenland and Antarctica have changed over 16 years.
We can actually see some processes at a scale that's almost long enough to tell us about the climate in those two places.
Scientists took ice sheet elevation measurements from 2003, overlaid data from 2019, and analyzed where the data sets intersected in order to see where ice was lost or gained. For example, the study definitively shows that the East Antarctic ice sheet, the largest of all the ice sheets, is growing.
But more importantly, what we find is that growing is more than offset by increased losses coming from the West Antarctic ice sheet, which is thinning very rapidly as it responds to warmer ocean temperatures, specifically in the Amundsen Sea embayment area.
The West Antarctic side, we're seeing strong thinning on the ice shelves, which is causing drawdown on the inland ice, on the grounded ice upstream. Most of that is being caused because of changes in ocean heat flux underneath the ice shelves, which is causing them to thin. And then consequently, the buttressing force is being lost against the grounded ice, and the grounded ice is then flowing faster into the ocean and causing sea level rise. In Greenland, we're seeing different signatures. Again, in the center of the ice sheet in the plateau, we're seeing increased accumulation. So there is a slight increase in mass in the center, but the overall signal for Greenland is one of thinning, and that is being caused by ocean and atmospheric signals acting all around the edges of Greenland.
So we're seeing 200 gigatons per year of ice flowing into the oceans, which is enough to raise sea level by about 2/3 of a millimeter per year.
Combine that with the almost 118 gigatons lost in Antarctica, and sea level has risen a total of 14 millimeters over the 16-year period due to ice sheet melt. It may seem small, but the small changes add up.
What we expect by the end of the century is, on the order of 2, 3, maybe 4 feet of sea level rise. And because we have all of our infrastructure that is built around the coasts, we have a lot of vulnerability to a meter change in sea level rise.
The potential impact from sea level rise is one critical motivation for the continued study of the mechanics driving the changes in the ice sheets.
If we can understand those mechanisms and how they've played out over the last 30 years, well, then we can start to look and think about how will those ice sheets respond to what we project the climate to be into the future.